Fine. So in the last class, we have seen log normal distribution. Agree? So we have seen log normal distribution. So what is log normal distribution? Just to give you a recap, any distribution whose logarithm will give you a normal distribution, but not the actual distribution. Okay. By default, it will be not be normal distribution, but when you apply a logarithm on it, okay, then the values which you get after applying logarithm will be a normally distributed. Okay, was that clear? And I will also shown you an example. Okay, and also it will be mostly right skewed. Okay, it will be mostly right skewed, and we have seen this example, income example. Fine. So now one more distribution, okay, which we would like to discuss is called as Pareto distribution. Okay, Pareto distribution. Fine. So let's try to understand this. See, it's a Pareto distribution is actually very interesting distribution, and also it is like very much you can find examples in our day-to-day life. Okay, see, it is named after Italian civil engineer economist. Okay, it's a power law distribution. Okay, the basis for Pareto distribution is the power law distribution that is used in so many fields. Okay, but the main thing over here is the Pareto principle is 80-20 rule, stating that 80% of outcomes are due to 20% of the causes, was named in the founder of Pareto. Okay, fine. See, the fundamental point of Pareto distribution is the power law, guys. Okay, what is power law says? 80% of the outcome will come from the 20% of the causes. Okay, 20% of the causes. Fine. And this is very much practically occurring. Okay, I will tell you a few examples. Okay, the main example, if I tell you, see, if you take the wealth, guys, if you take the wealth, fine, just like we have seen in this example, if you take the overall wealth distribution in India, okay, in India, overall health, 100% of the wealth, if you take, okay, 80% of the wealth, will be present between just 20% of the population. Okay, 80% of the wealth will be present with just 20% of the population, and remaining 20% of the wealth will be present among 80% of the population. Do you agree? Because if you see the billionaires, if you see the total wealth in India, okay, total wealth in India, let's say it is 100 billion, for example. Okay, and there will be top 20% of the people like Ambani. Okay, in India, if you speak about like Mittal and Ajim Premji, Wipro CEO, and few top billionaires, okay, they contribute to the 80% of the overall wealth. Okay, the overall wealth accumulated with this 20% of the people will be 80% of this, almost 80% of the uh 80 billions will be available with these guys. Okay, remaining 20% of the wealth will be present among all the remaining 80% of the population. Okay, do you agree? Same thing, even if you see the global level also, there will be some top billionaires or trillionaires. Fine, the overall wealth, if you see in the, if you just visualize in the world scenario, there are so many poor people, there are so many middle class people, okay, and there are very few rich people. Okay, when you see the in the overall picture. Okay, and also if you see the overall global wealth, right, it is present between only few people. Okay, some rich Americans or some Saudi people. Okay, okay, etc. like that. Fine, that means overall 80% of the world wealth will be present between just 20% of the population. Okay, and remaining 20 will be present between the 80% of the population. That is called power law, guys. Okay, that is called power law. Fine, and if you see, and also the point here is 80% of the area, okay, will be present between just 20% of the values. Fine. So if you see just this area, okay, if this is the overall graph, okay, maximum amount of area, okay, even let's say if this is 80% is, let's say, somewhere around here, okay, 80% of the area will be covered between just 20% of the values, okay, remaining remaining 20% will be covered by 80% of the people, okay, but the majority of the values will be covered by just 20% of the population, okay. And if I tell you few more examples, for example, see, wealth is an example which I have told you. Second is the app usage, okay, simple, practical, every day to day, which you can understand is, let's say in your phone, okay, let's say in your phone, you have multiple apps, right? Multiple apps, but let's say you have like 20 apps, guys, okay, 20 apps, but you can clearly observe that 80% of the time, okay, you just use just 20% of the apps, okay. 80% of the time is consumed by just 20% of the apps. That means what? Just two or three apps, mostly WhatsApp, Instagram. Agree? Even though you have 20 apps, 80% of the time is consumed by just 20% of the apps. Okay, but this is 20% of the apps. Fine. If you're getting that way, let's say you're having 30 apps. Okay, 30 apps. Okay. So 80% of the time will be consumed by just 20% apps. Remaining, okay, remaining 20% of the time you'll use for remaining 80% of the apps. Do you agree with this, guys? It is applicable to me because mostly I use, let's say, WhatsApp or Instagram. And what else? Yeah, that's it. Just two, three, four apps. That's it. Even though I have like 100 of apps, 80% of the time I spend with just only 20% of the apps. Is it true with you guys also? Can someone let me know? Or does this example work for you? Does your app usage follow Pareto distribution and power law distribution?
Yes, sir, it
Yes.
follows.
Yeah, mostly it is the same. And one more practical example also, if you see the project work division, okay, let's say you are in BTech, okay, and you are given a project, fine. Let's say you are having 5 people in your team, okay, and it is very common that 80% of the work will be done by only 20% of the people, okay, 20% of the people, okay. That means what? Just one or two people will be doing the 80% of the work. Remaining 20% of the work will be done by 80% of the people. That means remaining 3 or 5 people. Okay, but majority of the work will be done by minority always. So that is the main part concept here. Majority contribution will always be present between the minority people. Okay, so it's always the minority which rules, guys. Okay, minority in the sense a small group. Okay, a small group will have the major contributions in any given scenario. Okay, like this, I was able to just think of these examples, but you can extend this, and if at all, as of now, if some example strikes your mind, okay, you can let me know. Okay, but uh, there are lots of examples. There should be lots of examples which follow a power law distribution. Okay, and I also think this project work distribution will also follow a Pareto distribution, because even in my scenario also, when I was doing the BTech, only me and my friend was doing the overall project, even though we had like 5 or 6 members. Okay, that means 80% of the work is done by just 20% of the people. Agree? Yeah. And also see everything. See, I was able to just think one more example. For example, if you take the what was it, the syllabus completion. Okay, if you take the syllabus completion, 80% of the syllabus you will complete in the just 20% of the time. Okay, just 1 or 2 days before the exam. Agree? Remaining 20% of the syllabus you may take 80% of the time. Okay, rough example, but mostly the point here is majority of the things will be done in a minority of time. It was applicable to me because we used to do like 1 day batting or 2 day batting, right? Almost exactly like almost 80 or 90% of the concepts we used to just study 1 or 2 days before. Okay. So yeah, so these are the few examples, but the main thing is it follows a polar distribution stating that 80% of outcomes are due to the 20% of the causes. Okay, and this is a graph. Fine, yes. So this is one of the distribution. Okay, as we move ahead, we will be seeing different distributions. Okay, fine. But today's the most concept, the most important concept which I would like to cover is transformations, guys. Okay, fine. See now, let's try to understand transformations. Fine. Now, what is transformation and why it is needed? Fundamentally, now, what is our position? We understood normal distribution. From there, we understood standard normal distribution. Okay. And then we also understood if any distribution is able to if it all is if it is already present as a normal distribution, then we are lucky and happy. But if it is not present, then somehow if we are able to convert it into normal distribution, then what we say, our work will be much more easier and we can bring out so many results. Okay, because so much of the work or research on the normal distribution, standard normal distribution is already done, okay, and available over there in the form of rules and formulas. So if at all we are able to convert it into normal distribution, okay, we will be able to understand the given data or apply it to any machine learning algorithm in a much better way. Okay, now that's our understanding. Fine. So after that we also saw, okay, all this is fine, but if first of all you should be able to know whether a given distribution is a normal distribution or not. Okay, then only you can apply what all you want to want. Okay, then to find if it is a normal distribution, okay, to find if it is normal distribution, can someone tell me what techniques we used here to find whether given distribution is normal distribution or not? What did we use? How did we find out? What is the famous thing we used here? Oh, if you don't remember this, then I think there's no point. No one?
Can you please repeat something, sir? I mean, find normal distribution. Technique.
To find whether a given distribution is a normal distribution or not, what did we study for this?
It should be in the bell curve.
How will you know that it should be in the bell curve? Guys, so it's clearly visible that you guys are not revising or you are not revisiting the class and you are not making any notes. So
By using QQ plot or
yes, yes. So obviously you are the guys who are going to lose, guys. Okay, so all the things which we are discussing, all the courses, all the hard work which we are doing in the early mornings, obviously it should benefit you, right? So when I'm doing my part, so if you guys are not okay following the concepts and if you're not able to recollect the concepts, then obviously you will lose. Okay, so when you're spending so much of time and energy, there should be some results, guys. So I leave it up to you guys. Fine. So because it's not been more just in last class or last class before one class. I think last class itself. Yeah, we have discussed QQ plot. Okay, the fundamental point I have shown you the examples also. The fundamental point of QQ plot is to find out if given a distribution is normal distribution or not. Okay, we have seen the example of normal distribution and we have seen the example of uniform distribution also. Fine. Okay, fine. That's we'll see. Okay, so here then to find out a given distribution is normal distribution or not. So we have seen QQ plot. Okay, quantile plot. Fine. So this is fine just to find out if a given distribution is normal distribution or not. Okay, if it is normal, okay, if it is yes, okay, if it is normal, fine, then you go and use all the rules of the normal distribution. But if it is not normal, okay, QQ plot will only detect, right? So QQ plot, what does it do? It will only tell. So here we are lucky that it is already by default, it's a normal distribution, then it's okay. But what is the purpose of QQ plot? To just detect, okay, or just show whether given distribution is a normal or not. It will only help till that much. Okay. But next, the fundamental thing is, if at all it's not normal, what we need to do? Okay, if at all it's not normal, what we need to do to convert it into normal? Okay, if it is no, then we need to apply some transformations. Okay, then we need to apply some transformations. Okay, so that is the reason we are going to study transformations. Okay, so at a high level, we have mathematical transform. Okay, we have mathematical transformations. So there are like it is divided into mainly two types. Okay, one is one side you have like log transform, reciprocal transform, square root transform. Okay, and second thing is Box-Cox transform. Okay, Box-Cox, Box-Cox, and Johnson. These are the names of the scientists. Okay, two scientists, one is Box, other one is Cox. Okay, that's why they named Johnson. Okay, fine. But how we are going to use these? Okay, are using the SKLN. Okay, in the SKLN you have two types of transformers. One is functional transformer. Okay, functional transformers. Fine. Second thing is the power transformers. Okay, in functional transformers you can use all these three. Okay, log, reciprocal, square root. Fine. In power transformers you can use these two, Box-Cox, Geo. Okay, fine. But let me know if the theoretical concept why we should use transformations is clear or not, so that I can proceed further.
Yeah, clear, Santosh.
Okay, fine. So see, now first thing is, see, fundamentally what is transform? It is just if given a column, okay, we are given a column C1, okay, it's having some values 2, 12, 18, 8, 16, something like that. Okay, and when you have plotted this, okay, when you have plotted and when you have used, let's say, QQ plot or histogram, okay, so those sort of things, and you understood that this is not a normal distribution, fine, this is not a normal distribution. So obviously you want to transform or you want to convert this into some other column, okay, some other converted column. So let's say new column, so that the new values, that means what, each value will be converted into some new value, so that all these new values, when you plot it using QQ plot or some other histogram, they will be now following normal distribution. Okay, that is a goal. Fine. So if you want to transform, there are different ways how you can do transformations. Okay, those are these techniques. Okay, so that means, for example, if you just do, so even converting of normal distribution into standard normal distribution, even that is also a transformation, right? When in normal distribution you have some set of values, but when you convert into standard normal distribution, where mean equal to 0 and standard deviation equal to 1, you're also doing some type of transformation, right? Because once you convert into normal to standard normal, you will have some values negative, you will have some values positive, because the mean should be 0. Fine, that is also a type of transformation. Fine. So here, fine, so here also, what values, okay, what transformation I should apply on this, so that the new values will be what, following a normal distribution. Okay, that means what, for example, is to tell you simply, for example, if at all you think that these values are normal, not normal distribution, okay, but the reciprocal, okay, if you use reciprocal, means what, 2 will become 1 by 2. Okay, 12 will become 1 by 12. Agree guys? 8 become 1 by 8. Okay. So if you plot these values, okay, if you plot these values, they might be following normal distribution. Getting, okay. So then if at all, if you have applied the reciprocal, okay, transformation, and if it is following the normal distribution, then obviously that's called reciprocal transformer. Fine. So the why? Because the reciprocal of these values, okay, that means what? 1 by these values, the set of these are following a normal distribution. Okay. The set of these are following a normal distribution.
Okay, sir.
So, Santosh, here is also it may follow or may not follow, right?
Correct. Correct.
Either it may follow log, either it may follow reciprocal,
Correct.
either
Correct.
it may follow. Yeah.
Correct. Perfect. So we don't know which one using applying which transformation will give us a normal distribution. Okay. Then we will see what are the best techniques to find out which one will give you the transformation. But usually in the initial stage, you need to do trial and experiment. Okay. Because you don't know which transformation will give you the normal distribution. Okay. Fine. So first of all, we are going, let's see this log transformation. Okay. Log transform. Fine. So let's start. See, log transform is not a new thing actually. So log, if you just try to remember, so just now we have discussed what is something called as log normal distribution. Okay. Is it is the same concept in the transformation also. If you see in transformation, what I'm saying, the actual column is not a normal distribution, but applying some transformation, if you get a new set of data, and if that new set of data is following a normal distribution, then that is a transformation. Same thing, what did we study in log normal, guys? Log normal also, what we said, whose logarithm is normally distributed. Okay, isn't it the same thing? Whose logarithm is normally distributed. That means what? Its actual value is not normal. X is not normal. Okay, X is not normal, but its logarithm is normal. So obviously, what type of transformation we are applying is this is nothing else, nothing but this is log normal transformation. Okay, it's log transform or log transform or log normal transform. Okay, so when you apply logarithm to a given set of values, the new set of values will become a normal transform, normal distribution. Okay, so I'll try to show you an example, guys. Okay, so let's see. Fine. So this will be a bit lengthy example, okay, and which will also cover the concept of machine learning also. Okay, so you might not be knowing most of the concepts related to machine learning, but that's fine. Okay, you don't need to understand machine learning, but I'll just show you how applying applying the log transformation or log normal transformation, you will be able to get better results. Okay, fine. So let's start, guys. Okay, just a second, let me take my pen. Is a theoretical part of log normal clear, guys? Because if that is not clear, then you will not understand the practical case.
Clear, Santosh.
Okay, fine. So here, what I see, the main thing what we are doing over here is, first you are taking a data set. Okay, you're taking a data set, and in that you are selecting some columns. Okay, some column selection. After that, okay, after that you are directly applying some model, machine learning model. Okay, machine learning model on top of this. Okay, we are applying actually two things. One is logistic regression, other thing is decision trees. Okay, don't worry about these things. Okay, so these are just machine learning algorithms. It's a classification models. Okay, and we are going to see the results. This is on the raw data. After that, we are going to apply some transformations. Okay, transformations, And then again, we are going to apply these two models and we'll see the results. Okay. And then we are going to compare the results and then understand whether applying transformation is helping us to achieve any better results. Okay. Because ultimately, whatever you, as I said, whatever you study in statistics, that should help us in the machine learning. Okay. That is a goal. Okay. So why we are doing normal distribution? Why did we study normal distribution? I said because one of the application, if you see, okay, one of the application, if you remember, I would like to show you normal distribution application. See, assumptions of machine learning algos. Okay, so that means what? Most of the not all, but many algorithms, okay, work well when the given data is normally distributed. Okay, so but there are some models, okay, which doesn't care much about the given data is a normal distributor or not. Whatever the type of distribution, it can still work great. And one of the example is over here, decision trees. Okay, so decision trees works well with almost any kind of data. Okay, but logistic regression works well with a normal distributed data. Okay, so I'm not going into the model details. Okay, but our goal is to understand how transformations are helping us to achieve better results. Okay, so fine. So guys, I'll be giving you a walkthrough of this notebook, what's happening. Okay, anywhere if you don't understand or finding difficulty, just stop me over there. Okay, so but make sure that you understand that how applying transformations is giving us better results. Okay, anywhere theoretical or the practical, if you're get stuck, okay, feel free to stop me. Okay, fine. So fundamentally, we are using some data set called as train data set. Okay, in train, what is this? Train data set is what we are using a Titanic data set, guys. Okay, Titanic is one of the initial, okay, I would say the entry level data set for any data scientist, learner, or aspirant. Okay, so there are some this called toy data set. Okay, so for example, Iris or house price data set or Titanic data set. Okay, so there are like a bunch of data sets which will be the entry level data sets. So that to understand the different concepts, people usually use or do some hands-on on this data set. Okay, first of all, if I show you the data set. Yeah, it looks like this. Okay, so the basic idea over here is, see, the basic idea over here is this is actually Titanic data, guys. That means you already know famous Titanic ship called as RMS Titanic, okay, which where we also have a famous movie that is also done based on this, okay, Titanic tragedy. Okay, so here what happened, as you know, that Titanic was it's one of the world's largest ship, and they have started on a world tour, and at some unfortunate night, okay, when people are in some enjoyment, okay, they overlooked a iceberg, okay, at in Pacific Ocean, and okay, misfortunately, okay, the ship has just collided with a small part of the iceberg. Okay, unfortunately, it got collided with the tip of a small part of the iceberg, and then a small portion of the ship broke. Okay, and water started coming in. Fine, and then slowly and slowly it started, okay, sinking the ship, and then they understood, and then what was the engineers and the ship coordinators or the admin staff or the owners, okay, they have decided to save some people, okay, as much as possible. Okay, most of the women and children are saved, okay, but most of the men lost their lives. Okay, so this is a background of this data set. Now, interestingly, we can convert this into a machine learning problem, and you can predict. Now, what is the input? What is overall data set? Yeah, first we'll understand overall data set columns. Okay, passenger ID column, survived. Okay, whether a person has died or he was alive. Okay, one is alive, zero is died. Fine. and class, which passenger class. So as you can clearly see, we are having different types of classes, 1, 2, 3. So even in the movie also, the hero Leonardo DiCaprio, he was from the third class, and the heroine Rose was from the first class. Okay, have you guys seen Titanic movie?
Yeah, Santosh.
Okay, fine. So there are 3 classes, okay, and its name of the people, fine, and 6, whether the person is a male or female, and his age, her age, okay, and these are some other ship related data. So SIBSP parts, I don't know what are this, okay, ticket number, fare, okay, fare. Now as you can clearly see, P class is 1. If it is P class is 1, that means first class, so the fare is high, you see, okay, and if it is P class is 3, third class, and the fare is low. See, 3, it is low, okay, and if you see again first class, it is bit high, 53. Agree? And also if you observe, guys, that's the reason when you have a data set, right? So it will be very interesting, first of all, to understand some things about the data. Okay, forget about machine learning, forget about everything, but first of all, if you have some understanding about the data, then obviously you will be very much interested. Okay, just by looking at this, you can do some observations. Okay, if I just apply one, see, the fares are bit high. Can you see? 71. See, this is some 146 actually. So who is this guy? She's some female, and Mary Agnew. Okay, Spencer, Mrs. William Augustus. Okay, I don't know who is she, but she has bought a very costly ticket. Might be she's having some separate room or some luxurious VIP room. Agree? And just if you do it over here, you can just find some funny observations. Okay, so here if you observe, yeah, the highest value I can see is for 512. Yeah, who is this person's? Okay, Ward, Miss Anna, Thomas Ray, Gustav. Fine. So see, all of them bought the same ticket number. That means I think they are from one family. Fine. Same fare on one ticket. There, I think 3 people are following. Agree? And now, if I go for some, and also if you see, for these guys, cabin numbers are also mentioned. Okay, most of the persons cabin number is also mentioned. Fine. So, but if I go to 3, okay, see, third class, the prices are very, very low, 7, 8, okay, almost, and there are no cabin numbers. Fine, it's like a general compartment in our trains, and in the movie also they show, right? So the hero will be in like a general compartment where they will be playing cards, etc. Fine, and that's what those are the few examples which I make, and it's practically syncing also, right? The according to the given class and the fare. Okay, that's fine. Now our goal over here is use this data. Okay, use this data. Okay, and train a model, ML model, so that it can predict. Okay, if given a new data, it should be able to predict whether the person has survived, okay, not survived or survived. Getting? First of all, you will train on this data. After that, when you give some new data, like if you say randomly, if my class is 3 and my name is, let's say, Leonardo DiCaprio, and my sex is male, age is something, okay, this is something, okay. And if I give this new row to this model, it should be able to predict whether this person has lived or died. Okay, so that is a basic machine learning model goal, any machine learning model, to do some predictions. Fine. So is a data set, is a problem statement clear, guys? Is a data set clear? And also the problem statement, what problems we are trying to solve? Is that clear? Let me know.
Yes, sir. Yes.
Okay, cool. So now we'll go to our data set. Okay, I'll just give you walkthrough. So initially, see, pandas, numpy, scipy.stats, okay, pandas for data frame, numpy for just for numerical calculations, scipy for some statistical functions, okay, matplotlib for visualization, seaborn for visualizations plots, okay. Model dot selection train test split is just if you're having the overall data, see, I'm just giving you overview, guys. Okay, I'm not focusing more on this. As I said, the main goal is to just show you how transformations are helping us. But when in our machine learning concept, when we are studying this, right? So I am going to explain each and everything in very much detail. Okay, don't worry. You will understand the core of train test split, accuracy, logistic regression, everything you're going to understand. Okay. But I also hope that since you guys, okay, Meghana and Shirisha are already from data science background, so you will be having some basic knowledge about this. And Karthik, I'm not sure about you, but somewhere you might have also already heard some of these concepts. Okay, but still I'm going to give an overview. So train test split is nothing but you're having the overall data. So note, okay, never you will use the complete data for a training. Okay, you need to divide it into, because why? If you use the overall data on the training, okay, then what is the data for testing? Okay, there is no data left for the testing. So that's why you are going to split the data into training data and also test data. Okay, then you will train the model. Okay, the model will be trained on the training data. Okay, trained on training data and will be tested on the test data. Okay, so that's why to do this you need some library to split the data. Okay, that is train test split. Fine. Accuracy score to just predict how much accurate our model is, and cross-fall score is underscore. Okay, and the actual model is of logistic regression, and logistic regression we are importing from the linear model. Okay, this is sklearn is a package. From that you are having a library. Okay, sklearn library, linear model package. Okay, logistic regression module. Okay, and similarly from decision tree is imported from the sklearn.tree. Okay, now the most important things are two transformers. Okay, as I said, in sklearn you have function transformer and also column transformer. Okay, function transformer and what was the other thing is power transformer. Okay, function transformer and power transformer. Okay, fine. So here we are going to see function transformer. Okay, in other notebook we are going to see power transformer. Okay, so here also have something column transformer. Okay, we'll see. But main thing is function transformer is the one which has, what does function transformer have, guys? Okay, if you see function transformer is having log. Okay, log transform. Okay, we are going to see the example of log transform. Okay, so now fine, I hope this initial basics is clear. Okay, now going forward, okay, first thing is I have imported the data sets. Okay, I've imported the data sets. What is train.csv? In that I have just used age, fair and survive. Okay, for simplicity I've used only what age, okay, fair and whether it is survive. Okay, because using the fair, okay, the fair column indirectly have some knowledge about passenger class column. Okay, because class is more, fair is less, class is less, fair is more. Okay, and name column is not useful because whether you have survived or not doesn't depend upon whatever the name is. Okay, and sex obviously it will have an impact. Okay, but whether did we use, okay, okay, no, but fine, because this is not an example of a machine learning algorithm. Okay, this is just for the transformation algorithm, right? But when we are using the actual machine learning when you're studying machine learning, you use all these columns you can use. Okay, so as of now we have just used age, fair, okay, and the output is survey. Okay, so using three columns we are trying to predict. Fine. So now coming here, so how did we do that? Because when you read this train.csv, it will actually input all the columns. But if you use this parameter called as use calls, that means use only these columns. Okay, so it is imported only age, fair and survived. Okay, fine. Now next df.isNull.sum. Okay, df.isNull.sum. What it will do? It will just give you the sum of the null values. That means if any of the column is having null values, that means if there are no values present, this is one of the big red flag for any model. Okay, because the input of the model is data. Okay, there should be some data so that you will understand some pattern. Okay, there should be some data at least. Whether it is positive, negative, zero, any value it is there, it will try to understand, it will try to build on top of that. Okay, but if the data is not present, that means it is having null values. Okay, the model cannot assume any value by itself. Okay, then that is a big red flag for it. Okay, and it will definitely affect the performance of the model. Okay, so that's why fundamentally we will see if there are any null values in the given data or not. Okay, so the function for it is data frame dot is null. See, df is my data. That means the overall data set what we have imported will be present in our df. Okay, now we will use df to do all our work. Okay, and everything what you are doing, it is in the pandas. Okay, so we are going to see numpy pointers also, but I would say this will also help you to give a good start, okay, of what all the things we are going to study in near future. Fine. So df.isNull.sum will give you the sum of null values. Okay, see survived is having uh is having null values. Age is having, okay, 177 null values. Fair is having no, sorry, no null values. Okay, so it's not zero. Okay, survived is not having any null values. Okay, but age is having 177 null values. Fine. And fair is not having any null values. Null values what empty values. Okay, but if you see, he's saying age is having 177 null values. Okay, let's see that. Okay, so if I go here, and what are the columns we have considered, guys? We have considered only let me just hide other values. Okay, passenger we not consider, class we not consider. Okay, we or let me just take only those columns into new sheet. Okay, one is survivor, age, fair. Only these three columns.
Yes, sir.
Okay, these three columns. Fine. So now if I just put a filter, so he's saying what? Is null will tell you any null values. Survived is not having any null values. That this is the count of null values. Okay, dot sum will give you count of the null values. Okay, age is having 177 and fair is having no null values. Okay, we'll see. Survival. Okay, only 0 and 1. Apart from that, there are no null values. So that's why it is having 0 empty values. Okay, fair is also having, see, fair will be 0 or any other value, but it is not null. Okay, coming to age. Okay, coming to age. Can you see blanks? That is a problem. Okay, if I come here, okay, see how many are there. So if I just select, can you see the count here? 177. Right, so this 177 is what it is saying over there. So it is saying 177 are the null values. Okay, fine. So after that, what we are going to do, since machine learning doesn't work with null values, we are going to replace the data with the average data. Okay, so usually, as I said, we will either go by mean, median. If it's categorical, we go for more. Okay, mostly we'll go by the mean, average value. Okay, so now we have filled the null values with the mean. Okay, so that's the reason. So now as we move ahead, you will see the applications of most of the concepts which we have studied right from the class 1 in the statistics. Okay, so we are the way how we are filling the, it is, we are saying df dot age. Okay, that means you are accessing the age column because age is having 177 null values. Dot fill na means what? Null values. Okay, fill na values. How I should fill? Using df age dot mean. Okay, so that means in place is true means it will use the same data set. It will not create a new data set. Okay, so here what's happening is first it will calculate df age dot mean. Okay, this will be calculated. That means what? It will take this column and dot mean will give you the average value of it. Okay, and that value, let's say I'm assuming it as, let's say, 26. Okay, so this 26 will be replaced by all the null values. That means wherever you are having null values, that means 177 null values will be replaced by 20 sorry 26. Okay, so that's how we are filling the null values. Fine, so that's fine. Okay, so if I just show you, if I okay, it is not okay, so just give me a second, I'll show you. Okay, results are importing. So today I'm going to extend class for some time. Is that fine, guys? So that we'll cover this transformers concept, so that from Monday we can start a new concept called a central limit theorem. Okay, so Risha said okay. Others?
Yes, sir.
Okay, fine. But if it is too much for you, you can let me know. Sir, we are not understanding, sir, like that. But we'll take it slowly. Okay. So now if you see, but I think this should be interesting because you're also studying a bit of machine learning also. Fine. So see, first of all, I have imported the data. Okay, I got the data, and I'm seeing null values. Okay, so many 177. I don't want that. So I am doing fill NA. That means what? See guys. So df of age dot mean, it will first calculate. Okay, what is the mean? 29.6 is the mean of all the values. Okay, and it will replace wherever you are having these null values. These 177 values will now be replaced by 29.6. Okay, so let me run this. Okay, now it is replaced. Once it is replaced, now if I do this again, can you guess what should be the values now?
0, 0, 0.
Yes. So can you see 0, 0, 0? Fine, because all null values are replaced. Perfect. Next, this is a head. Okay. So then what I'm doing, I'm taking x and y values. Okay. So what is your x? What is your y? My x is just age and fair. Okay. Age and fair is my x. That means what? Input. Okay. What is the fundamental point we are problem we are going to solve here? Using age and fair, I want to predict survive. This column is a output column. Okay. The y is survived. Okay. So you're doing the same thing. This is x. How you're taking x? I am saying df.ilog. Okay, iloc is also a pandas function, but just let you know what it will do means it will select the rows and columns. Okay, if you want to select only specific rows and specific columns, it is used. Okay, just to give you a syntax over here. Okay, so all this we are going to see in detail in next classes, but see, just to give a detail, what does iloc do means in iloc you will have two things, guys. Simple. You will have a comma. Before comma, it will be for rows, and after comma, it will be for columns. Okay. So here also you can say from which row to which row you want to take. Let's say from second row to 10th row. Okay. And for this rows, what columns you want to take? First column to fifth column. Okay. For example, like that. Okay. So if you don't give anything over here, that means if you just say give like this and leave it, and here only if you say just like 1 and 2, okay, then what it will do? If you don't specify anything, it will take all rows. Okay, it will take all rows. Okay, and here obviously if you're mentioning something, if you say 1 to 2, it will take from 1 to 2 minus 1. You remember in Python n index minus 1. So it will take 2 minus 1 1. Okay, that means one column. That means first index 1 column will be considered, but all rows. That means indirectly you are saying select column 1 and all rows. Okay, is this clear? Okay, let's make this class interactive. Okay, in this notebook, so that
Yes,
based
yes.
upon your understanding only, I can proceed further, because I can just see, guys, I can just give you a fast walkthrough. I can just tell you, sir, this is this and this is that. Okay, it's done. I can do that. Okay, but it will not be no use for you or me. Okay, so that's why I'm taking some time. Fine. So is this clear? iLog clear?
Can you please repeat once, Santosh? Just
See, iLog will take two things. One is you have a comma inside it. Okay, can you see this comma? This comma. Okay.
yes.
One is before comma, after comma. Before comma is for rows, after comma is for columns. Okay, simple. So it's very simple. In rows, you should mention what rows you want to pick. Okay. So from which row to which row? See, overall how many rows you have? See, overall how many rows you have? If I just remove the filter, you have 892 rows. Okay, 892 rows you are having. And how many columns you are having? 3 columns.
Yes.
Agree? So using iLog, you can select a subset of this. You can say I want only from 10 to, okay, sorry. You can say I want only from 10 to 24 rows, and in that I want only B and C column. Okay. So that you can do over here. So here you can say 2 to, I want row 2 from row 9. Okay, to second row to 9th row, and in that I want only first to 4th row, 4th column. Okay, that is how you can select. So here, but if you don't mention anything over here, it will take all the rows. Okay, so that's why here what we are doing here, I'm doing select all rows. Okay, I'm just giving semicolon and leaving it. So it will take all the rows. But for the columns, what columns I want, guys? I want only age and fair. Agree? Now, what is age and fair? Age and fair are over here. So survived index is 0. What is index of survived? This is 0. Age index is 1. Fair index is 2. Simple. So that's why I'm saying take columns from 1 to 3. 1, 2, 3 means what it will do? It will take till 1 and 2, end index minus 1, 1 comma 2. So it will take age and fair, columns age and fair are selected, and rows, I want all rows. Okay, I want all rows. And that's why I'm not giving any rows. I'm just saying colon and giving comma. Okay, it will take all rows. Is it clear?
Yeah, Santosh.
Okay. So, and coming to y, survived. So you can directly take only one single column. So here I'm not giving any range. Okay, I'm not, that's why I'm just saying 0, only 0. That means only survived column, but all rows. Rows, I want all rows, because rows you will always give all rows to even train data or test data. You will not touch the rows. Okay, because only columns will be different. Some will be input columns, some will be output columns, but whether it is input column or output column, you should have all the rows. Okay, fine. So now we have divided the data into two parts, X and Y. Fine. So now once you pass this X and Y, okay, passing X and Y, and when you once you put into train test split, okay, so it will give you, it will divide it into two parts. Okay. Let's say its test size is 0.2, that means 20% of the data is divided into test data, that means remaining 80% is for the training data. Okay, so I'm not going into detail how it is going to divide, but it will divide the overall given data into two parts. One is 80%, one is 20%. Okay, 80% is the training data, 20% is the test data. Okay, fine. Now training data is training data is wherever you see train, right? X train and Y train. Okay, these two are the training data. Okay, training data. And X test and Y test, these two are the test data. Okay, just remember that much. Okay, understanding that much is enough for this notebook as of now. Okay, so now you have divided the X and Y, okay, input and output. In that you have divided into training data and testing data. Okay, fine. Now the main concept we are going to see is, okay, okay, the main concept we are going to see over here is without, okay, first of all, let's see some distribution, guys. Okay, that is important. Okay, what are the two input columns? Simple, age and fair. Only those two are the input columns. First of all, if you see the graph of age and input column, so these are the QQ plots. Okay, first of all, you should understand whether your given columns are normal distributed or not. Okay, so for that you are drawing two graphs. Okay, one is what? One is SNS dot distribution. Okay, SNS dot distribution will give you what? The actual distribution, the KD plot it will give you, kernel density estimation or normal probability distribution. Okay, it will give you. So for the age column, as you can see, okay, this is a distribution. It's not perfectly normal, okay, but it's okay. Okay, and coming to the QQ plot, so you can use stats dot probability prop plot. Okay, so in this, if you give, okay, it is going to give you the QQ plot. Okay, so these two are the graphs. Okay, the actual given age column data. Okay, and you can see some peak. Okay, that means somewhere around 30. Okay, somewhere around 30. It is having high value. Okay, so it is just a density, that means frequency or probability. The y-axis is frequency or probability or, okay, density. For each X is the actual values in the given data set. Okay, and this is a distribution. Okay, and this is a corresponding QQ plot, guys. Okay, this is a corresponding QQ plot. Okay, okay. By observing this, we can not say it's perfectly normal, but it is still okay. Okay, because most of the values are on the red line. Okay, this red line is this red line is a normal distribution line. Agree? I hope you remember the concept. Okay, so most of the values are falling on that line, so it is near normal. Okay, you can say it is near normal. Okay, fine. Is this graph clear, guys? Were you able to understand this? Okay.
Yes, Santosh.
Fine. So now, similarly, we'll also see for the fair column, only two input columns, age and fair. For fair, okay, so this is a distribution. As you can see, it is clearly right skewed. Okay, can you see this right skewed? Fine, and fine, and if you see the QQ plot, it is not perfectly no, it is not a, oh sorry, it is not a normal distribution. Agree, it is not a normal distribution. Okay, and it is a bit of right skewed. Okay, it is a bit of right skewed. And why it is right skewed, guys? Can you take a guess? And what is the distribution which we studied, which follows right skew?
It's a logarithm
Logarithm
distribution.
transformation.
Sorry, I don't understand.
Logarithm distribution.
Okay, what is the exact
And
name of it? Srisha, you are saying
Log
something?
normal.
Correct. Okay, so it's a log normal. Fine. Log log normal distribution is a kind of right skew. Sorry. That means what? Many people will be having like less values or medium values, but only few people will have maximum values. Okay, and I think that is also possible, right? Because the very costly prices will be bought by only few people. Agree? What is x on x-axis we're having fare, that means ticket price. Okay, and y-axis is density, that means how many people bought it. So very high ticket prices will be bought by very few people. Agree? Very rich people. Okay, and also as you can see, what if you remember what was the maximum ticket price which we just saw in the notebook?
512.
512, right? So that's why, as you can see, this blue color, see this is 500. You can see a line till here. Okay, so this could be 512, and it is frequency is very less. On y-axis, you don't have any height itself. That means almost very less amount of people. Okay, one or two, three people only, right? Yeah, we have seen three people from the same family. Okay, bought the ticket. So that's why this is creating a right skewness. That means what? High amount of values are bought by very low amount of people. Okay, but low prices are bought by many people. So if you can see prices between like 0 to 100, that means 70 or 80, okay, those are bought by major of the people. But as the prices are increasing, the number of people buying will always decrease. Okay, because not every people is rich, not anybody, not all can afford that amount. So that's why the number of people who are buying will keep on decreasing, and it is following a log normal distribution. Okay, so one more example we got. Okay, clearly. Okay, this is not log normal we have seen, right? Same scenario. Okay, and I said log normal is very much available in nature. Okay, most of the time you will come across this. Okay, fine. So we understood that fare is following a log normal. So obviously it is not normal. So from QQ plot also you can see many deviations over here. Okay, fine. So this is what? This is the raw data. Did we apply any transformations?
No.
No. Plain data, raw data. We have just what I've done. We have just tried to handle some null values. Okay, we have just handled some null values. That's it. And we came over here. We divided the data, and we are able to see the transformations. Okay, it is not that great. Okay, fine. So without applying any transformations itself, let's train the model, guys. Okay, let's train the model. So see here, I have trained two models. One is logistic regression. One is decision tree classifier. Okay. So two models I have trained. Okay, I'm not going into these details. Okay, so it is not necessary as of now. So, but the main concept is here I am importing the models. Okay, models are imported. After that what? So then we are just see dot fit will just train the model. Okay, dot fit will train the model. Okay, CLF is my logistic regression. CLF2 is my decision tree. So here I am doing dot fit means I am training the logistic regression. In the second line, I am training the decision tree. Okay, fine. So after that, here I'm predicting. Okay, see, as I said, the one main thing is you are having training data. The model will be trained on the training data. Okay, using the training data, you will train the model. Once training is done, you will use the test data. You will use the test data for what? For some predictions. Okay, this is a fundamental point. Okay, as you can clearly see here, for dot fit, that means for training, you're using the training data for both the models. Okay, once the training is done, for predictions, as you can see, for dot predict, you're using the test data. Okay, for the model 1 and also for model 2 also, you are using the same test data for the prediction. Okay, so once you get the predictions, okay, these are the predictions you got, ypred and ypred1. Okay, these are the predictions which you got. Okay, so using these predictions, you can find out some accuracy score. Okay, simple. There are three steps. One is training, one is testing, one is score. Any model, the skeleton, the format, the background will be same. Fine. So we have trained two models, tested two models, got the predictions, and we have saw the accuracy. Okay. And now the accuracy, if you see for logistic regression, it is 64. For dash entries, it is 68. Okay. So as I said, remember logistic regression, there will be some effect on the logistic regression because logistic regression is also called as parametric model. Okay. There are two types of models, parametric, non-parametric. Okay. But I'm not going into detail. But only thing is parametric will require some of the assumptions like the data should be normal, okay, or etc. Okay, but for decision trees it's not like that. Okay, they're very robust algorithms, they're very like strong algorithms, they can work with almost any kind of data. Okay, so keep that in mind. So but now we have seen without any transformations, we have seen that logistic regression is getting 64% accuracy, decision tree 68. Okay, are we good till now? Let me know, are we good till now? Did you understand the code till here?
Yes, sir.
Okay, perfect. So this is just the basic thing we have done. Just took the data, saw the distributions without any transformations, load some model, see the accuracy. That's fine. But now the main goal of this notebook is to see, apply transformations and see whether we are giving any good results or not. Okay. For that, now the main game starts. Okay. So if you see the function transformation, from where we are getting the function transformation, so we are getting from here. Okay. From SQL or tree processing, we are importing function transformer. Okay. So in that function transformer, what do we have? We have something called as function np.log1p. Okay, this is log function transformer we are doing. Okay, but why I'm doing np.log1p? Okay, there is a small reason. Okay, so I'm not doing log p. I'm not doing log p. I'm doing log. Okay, 1p. That means what? So the basic thing is logarithm for 0. Okay, do we have any log? What is a logarithm for 0? What is log of 0?
1.
1.
No, log 0 is undefined, guys.
Log 1 0.
Okay.
Log 1 0. Okay, log 1 is 0. Okay, log 1 is 0. Okay, but log of 0 is undefined. Okay, log of 0 is undefined. Okay, that means it will not touch the origin. If you see the example, see, it will start from somewhere minus infinity and it will go to infinity, but it will not touch at 0. Okay, so that's why this graph, this graph will never touch the 0. So that's why logarithm of 0 is undefined. Okay, logarithm of 0 is undefined. Fine. So now coming to where was I? Okay, we are in this, sorry. Yeah, so that's why what I'm doing here is instead of log, I'm just using log 1p. What it will do is, the reason is because in our data set, okay, so wherever it comes across 0, okay, because a 0 is not, okay, because a 0 of log of 0 is not defined, okay, it will just add 1 to that. Okay, it will just add 1 to that and it will do the log of that. Okay, it will add 1 to that, and it will do the log. For example, if the price is 70, okay, then it will do log of 70. That's fine. But if the price is 0, okay, then log of 0 is undefined. Okay, then we get stuck over there. Okay, we'll just add 1. Okay, adding 1 will not make much difference. Okay, so that's why we are using log 1.p. Okay, because if you see fair, I remember fair were having some 0 values, right? Yeah, see, fair was having 0 values. Okay, for all these values, if you apply log, you will not have any value, it will be undefined. Okay, the code fails. Okay, that's why you're just adding 1. Okay, adding 1 will not have a great impact. Okay, so that's why you are just using log 1p. Okay, so
Sir,
what
I have doubt.
yeah,
Log 1p అంటే log 1 into 0 కదా సార్?
1 into
ఒకవేళ ప్రైస్ వాల్యూ 0 అయితే
no log 1 into 0 కాదు, ఉన్న వాల్యూకి 1 యాడ్ చేసి దాని మీద లాగ్ అప్లై చేస్తుంది.
ఓకే సార్. అంటే నేను log 1 log AB ఫార్ములా అనుకున్నా. log A plus log B లాగా.
కాదు see, log 1p is accurate for x, so that's 1 plus x is equal to 1. Okay, అంటే ఏంటి, ఇఫ్ యూఆర్ హ్యావింగ్ log 1p ఏం చేస్తుంది అంటే 70 ఉన్నదాన్ని 71 చేస్తుంది. ఓకే, సో వాట్ ఆర్ ద వాల్యూ యూ గెట్, it will just add 1 to the given value. What are the value you are having? Okay, see, you are having this 7. Okay, it will add 1 to that 7.25. It will add 1. It will become 8.25. Agree? Then it will apply log on this.
Yes, sir. Understood.
Okay. Why? Because if even if all these values, even if you don't apply this also fine. Okay. But wherever you're having 0, okay, wherever you're having 0 over there, if you apply log of 0, then no value fails. So that's why to handle this scenario, we will for 0, it will add 0 plus 1. Then it will log of 1. Okay. Fine. So we are doing that transformations. Okay. So, and after that, once you do the transformation, now what we're trying to do, so the way how you can apply the transformation to your data is simple. Okay. See, and we are going to apply this data to only your input data, guys. What is our input data? Input data is X.
Price and age.
Yeah, correct. But that is now we have converted into other values, right? So what is our input data? Input data is X train. Okay, X train and X test. Okay, inputs. X is C. X is our input. Okay, see, X is our input, Y is our output. Okay, forget about the output. This is our prediction. We on prediction output column, we don't apply any transformer. Okay, that is our goal. Survival is our aim, is our target, is our survival column prediction. So we will not touch that. Okay, we don't have any work with this survivor column. Okay, so the overall our focus will be on the input column. Okay, so this is again one more important column. We'll discuss all these points in machine learning, but what all we are going to do, what all study we are going to do, okay, that is mostly 80% of the time it is on the input columns, guys. Okay, and only sometime we will try to do some encodings, and if at all it's based upon the output categorical or numerical, we will spend some time, but most of the time over here. That again, there is some power law over here. The Pareto law applies over here. 80% of the work and effort we spend will be on the input columns. Only on the 20% of it is on the output column. Okay, one more power law example. Fine. So that's why we are applying transformations on age and fair. Okay, over here, age and fair. X is the age and fair input. Okay, in that X we have converted into train and test data. So X train and X test. Okay, these two X's are our actual input data. Okay, these are just the output columns. Okay, so now that's why we have the transformations. Okay, we have transformations, and this what is my transformation function? TRF is my transformation. Okay, that I am applying on what? I am applying on X train and X test. Okay, X values, only X values. Okay, age and fair. And TRF dot, the way how you can apply simple, define a function, give the parameter, you will get the variable TRF. Okay, you will get the variable TRF. Okay, once you get TRF, just do fit transform. Use fit transform on your whatever the data you want to do. Okay, it will fit and it will also transform. Okay, now the new values will be transformed values of X train, X test. Okay, new transform values of this. Agree? Fine. So after that, these are the new values. Once doubt, Karthik?
Yeah, but for X test transformed, that second line, wouldn't use like fit transform? Is it function or like TRF
Oh,
dot?
okay. So yeah, that's a good question. When you do this, right? So only first time you need to fit. Okay, wherever you are using, only first time you can use fit transform. Okay, then after that you can just use transform. Okay, even if you have like 3 or 4, only first time when you do fit, okay, you need to use fit transform. That means fit is what? Train guys. Okay, fit is what? Train, similar to train. Okay, wherever you see the model. So whether it is model or any transformer, the first time once you fit it, right, so it will try to understand, but after that you can just use transform. Okay, so for all the transformers, you will see column transform, different type of transformers you will see. So here also you can use no problem, but usually first time you will say fit transform. Okay, after that you don't need to fit it again. Okay, it will just use transform.
Okay.
Okay, fine. So these are the new transform values. So now you have new transform values. Okay, now you are coming over here again, logistic regression, decision trees, fine. And then you have CLF dot fit X train transform, Y train transform. Here I'm using new this data, new data, X train transform, Y train transform. Okay, and after that you are fitting the data and fitting training, prediction, accuracy. Same thing will repeat every time. Train, predict, accuracy. Okay, now if you see the results, earlier I got what? Without any transformations, see, logistic regression is giving 64. After transformation, it is giving 68. Can you see improvement? 68. Okay. Coming to decision trees, it was 68. Okay, it was 67. It is decreased. Okay. Why? As I said, decision trees does not require any transformations. Okay, it is very robust by nature, and using transformations can have some reverse effect. Okay, so but there are some models like logistic regression which actually requires and some transformations or and because it requires the data should be converted to normal distribution. Okay, so when you do that, it will give better results. Okay, so logistic regression from 64 it went to 68 because we have converted into a new log normal transformations. Okay, and these are the results. And also, if I is this clear till now? Is it clear?
Yes,
Yeah,
sir.
Santosh.
Okay, fine. So after that, so the concept is clear, but now we'll see the transformed values also. Okay, so if you see the transformed values, yeah, the fair, okay, the fair column, fine. After transformation, so before transformation, how it was like, guys, this was the transformation. Okay, initially before applying any transformation, fundamental the fair column we took and we saw this is a PDF, this is a QQ plot. Sorry, okay. After that, what we did, we applied some transformation. Okay, then we got transformed values. Using transformed values, we train the model, we are getting good accuracy. Okay, but let's try to see how well these transformed values are. Okay, so we'll compare QQ plots before and after transformation. Okay, so now if you see the fair column, okay, if you see the fair column, fair before log, okay, fair before log, see the same graph is this one. Okay, same graph of fair is this. Okay, before transform, fine. After applying log transform, it is converted into this. Okay, so can you see somewhat better? Most of the it's like almost straight, fine. But here you can see most of the values, if not all, at least majority of the values are falling or very near to the straight line. Agree?
Yes, Santosh.
Yeah, so that's why so using log normal, okay, using log normal, you are able to convert this data into a near normal, not exactly, because 100% normal you cannot achieve, guys. Okay, even whatever transformation you use, okay, it's impossible to get 100% normal distribution. Okay, because it's completely different type of data. You cannot each and every data point you cannot convert into normal distribution. Okay, but even if you convert into majority or near normal, that's fine for all practical purposes. Okay, so after applying log normal, okay, so what did we do? We have just done log n1p. That means we are applying just 1 to each and every value and just applying log. That's it. Very simple mathematical application, nothing fancy we are doing. And new column, whatever you get. So when you do this, okay, you will get the and if you plot this, you will get this QQ plot. Okay, so as you can clearly see, there is a very good improvement. Okay, so this transformed value, okay, if you just want to see the transformed values also, so I'll share this notebook, guys. Okay, so yeah, I understand from yesterday you are asking like to share, but I did not get some time. So today mostly I will try to share the notebook, this and also other notebooks. Okay, this will be very interesting. Okay, do some experiments and play around this. Okay, see, you can also see after transformation also, this is before PDF, right? This is before QQ. Okay, now I'm showing before QQ, after QQ. But this PDF, what is a PDF of the this transform values? Okay, you can also have a look at it. Okay, this is not okay. I need to train this again. Okay, but however, since you understood the concept, you can just run this notebook again and then see each and every value before applying log transformation, how the PDF is looking. After applying transformation, how the PDF is looking. Okay, before QQ plot is how I'm showing the QQ plot. Okay, before and after. Okay, and similarly age also same. Okay, coming to age also, yeah, so age also same thing. So before applying the okay, before applying is this, and after applying it is actually, see, after applying it is it better before applying or after applying?
Before.
Right, so before applying only it's better, fine. So yeah, so that is one more that is one more point. So okay, see, I said all this concept which we are studying, right, so should be applied as per the requirement. Okay, so if you see in the first place itself, so age, it is looking perfect, almost normal. Okay, so here also almost normal, fine. So now that's why, but if you apply transformation on that, it is deviating from the normal distribution. Okay, it is applying or deviating from the normal distribution. Okay, so how you can again find out, you can again see the skewness of this data, kurtosis of this data, and also skewness and kurtosis of this data. Okay, so if the values are increasing, so obviously you are deviating from the normal distribution. So you don't need to apply any transformation over there. Okay, only if it is not normal, then you will apply. Okay, if the transformation is not giving any better results, or if it is not making your distribution, okay, come closer to normal distribution, then obviously there is no point of applying transformation. Agree? So that's why you need to check and apply. So here from this, I understood that only fair, okay, only fair should be transformed, but not age. Agree? Only fair should be transformed, but not age. Agree, guys? Or do you think it should be applied for both?
No, Santosh, only for fair is fine.
Okay.
Santosh, only I have one doubt.
Yes.
I mean, getting confused.
Yes, yes, yes.
Here we have theoretical quantities and ordered values, right? So that ordered values comes under like the
Yeah, ordered values are our values. Okay, so if you go back to QQ plot, theoretical values are the theory. Okay, that is from the normal distribution. Okay, so that which will create this line. Okay, a normal distribution by default it will take, I said, right? So in the
randomly we will take
sm.qq plot,
yes.
it will take a normal distribution values. Those values are
yes.
theoretical values, but ordered values are which you give or which you are giving, which you order.
Sample test data, like
test
what
data,
we are
our
giving.
fair data, our
Data set.
age column data.
Okay, yeah.
Okay, fine. Others, is it clear?
Yes, sir.
Okay, so now we understood that only fair
But
column.
how it will map, Santosh? How it will map? Both are like here.
It will take the quantiles, right? It will take the QQ. What is QQ plot? It will take the quantile of for normal distribution. One Q is from the normal, another Q is from the age. For normal, it already know by default the normal distribution quantiles. Okay, Q P1, P2. You remember P1, P2, P3 till 100 quantiles. And for this age column, okay, it is having some column, age column, transform column. And if it is transform column, obviously it is ultimately it is some column. It will have some values. If you have some values, you can calculate P1, P2, P3 percentiles.
Yes.
Just percentage.
100 percentiles.
100%. Yeah. So 100% from normal, 100% from sample. Just plot each and every value. Okay. For plotting any point, as I said, to plot any point in the space, what you want? X and Y, two coordinates. X will be what? P1 from the normal. And Y will be P1 from the sample. So like that, P2, P2, P3, P3. Like that, it will plot each and every point, 100 values.
Okay, but what if we have in for example, in theoretical we have taken randomly 100.
Why you will take randomly 100 values? Because what is your point over here? To find out whether the given distribution is normal or not, right?
Yes.
You can take normal, as I said, QQ plot. It works for any distribution. Okay, so in the QQ plot, if I go back, so over here, so in the SM QQ plot, fine. So by default, I'm just saying line 45, but I'm not giving any distribution. Okay, the dist parameter, okay, is by default normal.
Yes.
Agree? And only the test data set, whatever you want to give, you are specifying that column. So it will take this percentiles or quantiles, and for this normal also it will have percentile, and it will compare both these percentiles and we'll see whether it is following a straight line or not. If it is following, it is normal distribution. Agree?
Okay.
This is to test with the normal distribution. But as I said, QQ plot can be used for any distribution, even for the uniform. The other example also I gave here. Yeah. So for example, if you see here, here, if you want to test for the uniform distribution, specifically you are taking X and dist. Okay, here dist is what? Uniform distribution. Okay, you are trying to check test data with uniform distribution. Okay, but as you said, if you want to give some random, you can give. That means what? You are comparing with that random distribution, what you are giving. Let's call it as some Karthik distribution, just as an example. If you want to compare with that distribution, create some random distribution, give that in the place of dist, and give some sample, another sample test, and you see whether this X is following your normal Karthik distribution or not. That's your will and wish. You can do a QQ plot. Only the concept is give two distributions and see whether they're same or not.
Okay.
Whatever distribution you want to use. But the point here is we are using it to find out the normal distribution. Okay, by default, it will use the normal distribution.
Sure.
Okay, fine. So from here we understood that age, age column and the fair column. Okay, among these two, fair column is requiring some transformation. Okay, but age does not require any sort of transformation. Okay, fine. So that's why what you can do is using the column transformer. Okay, from where did we get this column transformer? If you see from above, okay, you are having this column transformer. Okay, so using this column transformer, okay, you can just select, only which columns you want to do the transformation. Okay, so if you see okay, column transformer, okay, you can say what type of transformation you want to apply. I want to apply log transform. Okay, that is function transformer input or log 1, for which columns? Only fair column. Okay, remaining columns just pass through. Okay, this will tell you out of all columns, okay, apply only log transformation to only fair column. Okay, because in this extrain, what you have fair and also age. Fine. So only for fair it will apply, and for remaining it will pass through. It will not apply for the age. Fine. So this is the transformation you are creating. Okay, this is a TRF F2 is a transformation which you created using this logic, and you are doing the fit transform. Okay, you are done fit transform. You are doing fit transform for extrain, and also you are doing the transform for what? X test also. Okay, this is a new transform. Agree? Is this clear, guys? Is this clear? Let me know.
Yes, Santosh. Like out of uh, 2 columns, just we are doing transformation for fair, and the remaining one we are just passing through.
Yes. Okay, fine. So using this transform, you're doing fit transform. Okay, using that you will get new columns. Okay, new transformations you will get. That means what? In this same thing you will have, but fair only will be transformed. Age will not be transformed. Okay, so after that you are applying the model. Okay, and fit predict accuracy. Okay, you are getting new accuracies. Okay, decision tree there will not be any change, but linear regression you are having some changes. Okay, you are having 67. Okay, earlier you got what, 68. Okay, so but it is bit better than the actual without any transformations. Whatever you are getting the 64. Okay, 64, that is these are 68 or 67 is also a bit better from that. Okay, so this is just an example. It's not like a thorough example to get the better accuracies. Okay, it's just to show you how transformations will give you better results or not. Okay, so just to give a recap. Okay, so initial data importings and handlings missing values, that's fine. After that we saw the basic without any transformations, basic distributions, age, QQ plot, that's it. Similarly, fair, QQ plot, that's it. From here only, from next time when you are doing any data set, okay, when you're working on any data set, at this point only you should have at least some guess whether you need to do some transformation or not. Okay, no need of by blindly going for transformations. Okay, over here only you can say, okay, it's almost near normal. Okay, but still you can go and apply transformation and check. Okay, there is no harm. Okay, fine. So you are seeing a, but you should have, it's almost near normal. Okay, but fair is completely deviating. Okay, it's a right skew. Okay, fine. Before applying any transformations, we have applied just to see what is the basic raw values, raw scores. Okay, raw scores are these. After that, we have applied log transformation. Okay, this is a special case log 1p, but fundamentally we have applied just log transform. Okay, after that we got transformed values. Fine. So using the transformed values, we have trained the model. Okay, you are getting 68, 67, some better. But after that we understood, okay, how does the transformed values look like? Okay, fair is looking better. Okay, before and after is very much better, but for the age it's not that great. Okay, it's not that great. Fine. So over there we have understood, okay, yeah, if at all you want to pass only one column and do the transformation, you can use this way and transform it only that particular column. Okay, and then you'll get the new models, transform models, and you can also train on top of that. Okay, so this is a basic example of how you can use a transformation and train a model. Okay, so actually we have seen a very important thing. Okay, if you have realized, okay, we understood normal distribution, and then we understood the transformers. Okay, then we actually worked on a data set where the given column is not a normal distribution, but still we have applied some transformation, got a new column. Okay, and we have applied the machine learning model on top of it, and we are able to apply so achieve better results. Okay, almost like end to end at the high level we are able to see. Okay, the fundamental goal will be always over here to achieve some better results on the model predictions. Okay, that is the main goal. Whatever you do, transformation, scaling, this, that, whatever concept you do, to get some better results on the output. Okay, and using the fundamental transformations, we are able to achieve some better results. Is this clear, guys? Is this clear, everyone? Any doubts, theoretical, practical?
Yeah, fine, Santosh.
Yes.
Okay, perfect. Post that, actually we have other transformations called as power transformations, box Cox. But shall we stop class here, or what do you say?
Stop, sir.
Okay, fine. Okay, so that's about the transformer, guys. So in the next class we will see box Cox and Eo Johnson. Okay, this is a general transformation, guys. Okay, this transformation will be general. Okay, so using from this only you will have all you can create all this log, reciprocal, square root. Okay, this type of transformations we are going to create. Okay, so we'll see that transformations, okay, on the next class on the Monday. Fine. So or I would say can you guys join 1 hour in the evening, guys? Okay, I just want to let you know, because my thought is, if you are able to complete transformations today, fine, so tomorrow you will have some time so that you can go through these concepts, and from Monday we can start like new concepts called as central limit theorem or some other distributions. Okay, but I just want to let you know, want to know your feedback. So this will take around like 40 minutes. Yeah, it's like around like 30 to 40 minutes, not more than that. What do you guys say? You can be honest, that's fine. So
For me, it's fine, Santosh.
others voting, it's voting time.
So it's what time, sir?
You can decide and tell me, that's fine. At evening or night time, 7 o'clock, 8 o'clock, anytime.
Okay, sir.
Okay, sir.
Okay, fine. Okay, so the aim is simple so that we can conclude this transformer concept. Okay, it's not that it will not be a 1 hour class, it will just a half an hour. Just one more application given the box class I would like to show. Okay, so you guys can decide and let me know one time. Okay, so we can have a group in chat in the group. Okay, so
Sir, in the function transformers, reciprocal and square root are similar to log, sir.
no, in the reciprocal and square root, so it's these are for this you don't need any special type of transformations. Okay, so you given data, if you just divide it by 1 by x, okay, if given data, if you divide by 1, you will get the reciprocal of that, right? That's it. For log you need to apply some logarithm. Okay, but for reciprocal, what is simply, if you have okay, so same thing. Okay, for example, if I take this example, fair, what is a receipt for log? For log, what you did, you need to import some functional transformation from that np dot log of 1p, all that's in my video. But fair 7.15 will become what? 1 by 7.25. This will become 1 by, just 1 by, reciprocal is what? 1 by. So you can just create your own custom function. Okay, you can create a small Python code, right? So the new values will be just 1 by these values. Okay, and you will get a new column. The fair column will be fair of fair reciprocal column you will have. Okay, every value will be 1 by 7.25 will be what? Some 0 point something. Okay, you will have a new values of it, and just plot this value. You will have some distribution, and again plot the QQ plot of this. You will get some other distribution. Okay, and for this also you see the plane distribution and also QQ plot. After transformation also you can see. From that you can understand, right, whether the before QQ plot is better or after QQ plot is better. Getting?
Yes, sir. Okay.
Did you understand,
Yes.
Sirisha? Simple. Given value,
Yes.
divide by 1 by x. X is what? Whatever the value you give, 1 by 16, 16 will become 1 by 16. Write a Python code just to reverse these values and create new column. That's it. For age also simple. 22 will become 1 by 22. Do the reciprocal of that. Create new column. Okay. And see before age and before transformations. Okay. Age is there. Okay. Before you will have some distribution of this we have seen, and some QQ plot of this. After that, do age reciprocal you will get. Okay, age reciprocal. After that also you will see one more distribution and QQ plot, and see whether before and after is better or before is better. If it is after is better, okay, then better to do the transformation. If before is better, you can use that column transformer to apply only the reciprocal, apply only to the fair, not to the age, and you see the accuracy values. Okay, so then like that you can try different things and you can decide. Okay, so you don't know which will work for what. Okay, for age, okay, for example, for fair, reciprocal might work, guys. For age, log might work. Okay, or for fair, square root might work. We don't know. Okay, so that you need to do trial and experiment, but using box Cox, which we'll discuss tonight, you will have some generalization. Okay, by default, how you can get. Okay, so that's why for reciprocal and square root, you don't need to have any specific example. Okay, so given the data, you can just do 1 by x and do square root. Also, what is square root, guys? How will you get the square root? What is square root? X. Square root of x is what? X to the power of 1 by 2. Okay, you will have math function in Python. You have math module. You remember math module?
Yes, sir.
In math, you will have square root, sqrt. Okay, so pass each and every value to this module and get the square root of 7.25. You will get some square root value. Create that into new column. That will become fair square root. And you got the new column. Just you're doing some transformation. That's it. So new these values converting into new values. Okay, once you got new column, apply again normal distribution. Sorry, just PDF graph and then QQ plot and see before and after which is working better or not. Okay, so these are straightforward transformations. Okay, these are very simple, straightforward transformations. Okay, square root and reciprocal. Log is something you need to use some function. Okay, and we'll see using Box Cox and Geo Johnson how you can do all this. Okay, so
Okay, sir.
yeah, you're saying something, Sirisha?
No, sir. Okay, understood.
Okay. So that's regarding the transformations, guys. Okay, so transformations are important because, as I said, even though we study or we love normal distribution so much, okay, practically you will not be given direct normal distribution. Okay, most of the time, for example, as I said, most of the scenarios will follow this log normal. The actual real life case of income distribution is not normal distribution, it is log normal distribution. Okay, but we don't know much about log normal distribution because we know many things about only normal distribution, all this. Okay, so that's why you need to convert this distribution, log normal distribution, into normal distribution using some transformations. Okay, like that, most of the cases, the given data, raw data, will not be directly a normal distribution. So it will not, your life will not be so much easy. Just you take the data, observe that it is normal distribution, and you apply all the empirical formulas or use adjectives directly. You can't do that. That's why you need some type of transformations. Okay, so further transformations is a fundamental concept which we have understood today. Okay, so I hope the theoretical and the practical code is clear. Okay, so and we'll try to like connect again and conclude these concepts. Okay, so that you will have the complete transformation conclusion. Okay, so that you can utilize today and tomorrow's time to go through these classes. Okay, so that's I'm stressing that again, guys. Okay, so no matter how much I teach or give you the concepts, right? So prepare all this and tell you, if you don't revise and if you don't okay, understand, it's no point in doing this. Okay, so that's why but I still understand, that's fine, because in stats it's very because you're studying stats for first time, it will be not that easy. All that is fine, but the only thing I'm saying is spend at least 15 to 20 minutes of time, make some notes. Okay, on that day only, just go 15-20 minutes, more than enough. Make some notes, at least the main concepts, if not the complete details. Okay, so that you will at least recollect and remember it's easy. Okay, so fine, guys, that's from my end regarding the transformations. Okay, tonight we will see other examples. Okay, so fine, is the class clear, guys?
Yes, sir.
Are we good? Okay,
సార్ డైలీ నోట్స్ డైలీ పంపియారా సార్ గ్రూప్లో?
ఏది
అంటే ఈరోజు చెప్పిన నోట్స్ ఈరోజే పంపించేసేయండి సార్. అంటే ఈవినింగ్ వరకు నోట్స్ ప్రిపేర్ చేసుకుంటాం.
ఓకే, ఓకే, బట్ ఈ నోట్స్ అంటే మీరు ఇప్పుడు ఇది ఓకే, సో just a
ఇదే
second,
సార్.
let me stop the recording. Okay, so that we can have the discussion. Stop recording.